Okay, we're going to do some factoring review. All right, so the first thing you should always look for is a GCF. All right, so GCF. All right, so let's look at this problem right here. 30x squared yz minus 45xy cubed. Okay, look for, all right, the numbers. What's the same or what goes into both of those? Make sure you're getting the highest. 15 is this. Notice they both have x's, but I have x squared and x. So I'm going to pull out the one that has the least because I think about it. I can't pull 2 out of the second one, out of the second term. All right, I can only pull 1. All right, and then I'll put in whatever's left over in parentheses in a second. I got y and y cubed. What's the least? Y. All right, now look at it. Do they both have z's? No, they don't. So I'm done pulling out everything that's alike so I can leave what's left. So 15 goes into 30 twice. I was left with one of those x's and the z. All right, minus 45 divided by 15 is 3. And then I took an x out, I took a y out, so I'm left with y squared. Keep looking in the parentheses to see if you can do anything else. In this case, I can't. All right, so we're going to move on. 8x squared plus 4x minus 2. All right, so I look at this and I think, all right, first off, I'm always looking for a GCF. Oh, 8, 4, and 2. A 2 comes out. I can't pull an x because there's no x right here. All right, so this is going to be just 4x squared minus or plus 2x minus 1. Now, again, you always want to look in this parentheses to see if you can factor any further. I'm going to go ahead and tell you this trinomial doesn't factor, but you're going to want to use one of the trinomial things to factor. So just heads up, you may not only be doing one of the factorings. Now, as far as, let's see, looking through my notes. As far as trinomials, these are the ones you need to be good at. This is the ones that you're going to see later on. You're going to see more in pre-cal. You're going to see more in calculus. They're the trinomials. All right, so let's look at number 3. Now, this is the most basic. So a trinomial is in the form ax squared plus bx plus c. All right, you've seen this before when you talk about quadratics and things like that, math 1, math 2. If there is nothing out in front, that means our a is 1. All right, that means this is just a quick factoring. You do 2 parentheses, okay, and you split it into x and x. Here, if you take our c value and you say, what are the factors of 2 that add to 3? Run through all the factors. We're lucky here because the only factors of 2 are 1 and 3, and 1 and 2, and they do add to 3. So positive 1 and positive 2. And I'll give you a hint. If all these are pluses right here, then it's going to be, both of them are going to be pluses. All right. Okay, let's look at number 4. A squared plus a minus 6. I'm sticking with the a value or the value out in front of our squared term as 1. Okay, so here we go. Create 2 parentheses and say a and a. You got to be able to get these quick, so you got to know your factors. Okay, factors of negative 6. Okay, if it's a negative, one of them is going to be negative. All right, and it's going to add to 1. All right, well, start off just with your factors first. Okay, 1 and 6, 2 and 3, add in a negative. Okay, well, when I add that, that's 5, so it's definitely not that. When I add this, that's 1. And do I want positive 1? Yes. Had I gotten negative 1 here, I would just need to change these 2 signs. Okay, so now it's negative 2 and positive 3. Whenever this is negative right here in front of your c value, then both of these parentheses, one's going to be positive and one's going to be negative. Okay, because the only way to get a negative number is if you do a positive times a negative. All right, number 5, p squared plus 12p plus 27. Okay, and at any time you can pause this and like practice yourself because you do need the practice. P and P, factors of 27 that add to 12. Okay, 27 is 3 and 9, 1 and 27, that's it. Do any of them add to 12? All right, yep, This adds to 12 right here. Okay, so positive 3 and positive 9. All right, moving right along. Okay, number 6. Let's see. Okay, well, I'm going to change this. Well, actually, let me do this first. So p squared minus 5p plus 6. All right, now this one's actually usually a tricky one. Okay, we do p and p like we've been doing, and we say factors of 6. Okay, factors of 6 are 1 and 6 and 2 and 3. A lot of people try to add a negative on the 6, but you can't do that because this is positive 6. They both have to have the same sign. Now, when I add that together, that's 7. Definitely not that. This is 5, but look what I want. I want negative 5. That means change both signs. Well, they're both positive right now, so now they're both going to go to negative. So negative 2 and negative 3. All right, so those are all the ones with the a value out in front of our square term as 1. All right, but what if we have something other than 1 as a? All right, we have 2 different methods for it, and I will do a little bit of both. Okay, the first one is trial and error. Okay, this is just taking this first term and saying, okay, the factors of this, of 2, are 2 and 1. I'm going to put x's with those. All right, the factors of negative 5. Again, because it's negative, one of them needs to be negative. So here we go. Negative 1 and positive 5. And again, this is trial and error that we're doing. So I'm going to throw 2x and x. Whatever these front numbers, plug them into the front. And then just plug these into the back, negative 1 and 5. I don't know if this is right. Okay, the way we check it is multiply these two, first and the last, and that's 10x. Multiply the middles, and that's negative x, and then this is 9x. Did I want positive 9x? Yeah, I just so happened to get it on the first try, and I did not mean to do that. Okay, now the other one is the AC method. That's when we multiply the first and the last. That's the A and the C together. So 2 times negative 5, times, and I end up with negative 10. You're still looking for factors, but this time, instead of just having 2 and negative 5 as my factors that I'm factoring, I have a little bit bigger number. That's the only drawback to this, because sometimes those numbers can get really, really big. Okay, or they have a ton of factors. Negative 10 doesn't really have a lot of factors. Negative 1 and 10, negative 2 and 5. Okay. So what we're doing is I'm going to rewrite the first, rewrite the last, and in the middle, okay, you got to pick out your factors that add to 9. Well, these add to 9. Okay, if it added to negative 9, I would just switch the signs. So negative 1x and 10x. All right, I'm splitting that 9x up using negative 1 and 10x because it doesn't add to 9. All right, now group. This is called a grouping right here. And we're going to pull out those Gcfs we were talking about earlier. So an x comes out, and I'm left with 2x minus 1. Let's see, a 5 comes out. Again, 10 divided by 5 is 2, so 2x minus 1. Notice those parentheses are the same. You want them to be the same. You take the Gcfs that you pulled out, you put them together. The parentheses that's alike, just write one of them. Does not matter the order of the parentheses. Did I get the same thing, though? Yeah, I got the same thing. All right, so that's how we can factor. All right, you got trial and error and you got AC. So I'm going to go back and forth. I'm not going to necessarily do the same thing with each one of them. All right, I'm going to choose one or the other. All right, so 2n squared plus 3n minus 9. I'm going to do this trial and error. Okay, feel free to pause it if you want and use one of the methods. Okay. This is 2 and 1, so I'm going to say that right there. Factors of negative 9. It is negative. 1 has to be negative, so negative 3 and positive 3. Negative 1 and 9. Okay, so here, 2n and 1n. All right, I don't know. Let's try negative 3 and 3 first. Okay, multiply the first and last. Okay, that gives me 6n. Multiply the middles. That gives me negative 3n. All right, that gives me positive 3, and again, just so happens to get this. Now, had this been negative 3 right here that I got, I would just change these signs. That would go to a positive, and that would go to a negative. Okay, let's look at number 9. 2x squared plus 9x minus 5. All right, so I'm going to do this one, and that's actually what I just did. Hold on. Let me go do a different one. All right, 5n squared plus 19n plus 12. There we go. All right, so my AC, 5 times 12 is 60. Factors of 12, that adds 19. Just start running through them. Okay, I know it's not 1 and 60. 2 and 30, definitely not 2 and 30. Okay, 3 and 20, nope, that's 17. Or not 17, that's 23. Let's see, does 4 go in there? 4 goes in there 15 times. Oh, there's my 19. So rewrite the first, rewrite the last. Okay, and split this one up using a 4 and a 15. All right, group, pull out, nothing comes out but the n, so 5n plus 4. Now that means this parentheses must be 5n plus 4 as well, and I notice, well, a 3 comes out, and then it is 5n plus 4. Put your two Gcfs together, all right, and then you write the one that you see twice, write it once. All right. Here we go. We're going to do another one, just like that. Okay, number 9, or I don't know what number this is. Is it number 10? Okay, 6x squared plus 37x plus 6. All right. You can do the trial and error. I'm going to do the AC method because I think some of you need to see that more than the other one. Okay, 6 times 6 is 36. All right, factors of 36 to add to 37. Well, that's pretty easy, 1 and 36. All right, so 6x squared. There's a 6, and then split the 37 up with a 1 and a 36. All right, group the first two, group the last two. X comes out, 6x plus 1. Remember, you had to have that placeholder if the whole thing comes out. Here, a 6 comes out. That's going to be 6x plus 1 again. Parentheses are the same, so we're good. X plus 6, put the Gcfs together, and the one you see twice, write it once. See if you got the same thing I did. All right, number 11. 9k squared plus 66k plus 21. Start looking at this, and a lot of you will automatically start thinking trial and error. But remember the first thing I said you always need to look for. You always need to look for a GCF. It's actually going to make it a lot easier if you find it. Like here, if it has one. Not all the time it's going to have one. A 3 comes out. So this is 3k squared plus 22k plus 7. This makes it a lot easier. Now, I'm going to see if I can still factor this, though. I'm going to do trial and error. The only factors of 3 are 3 and 1. Factors of 7 are 1 and 7. So I actually luck out. I make the number smaller. If I do the AC method, I get 21. That's not bad. But if I did the AC method up here, then I get this really large number I have to find all the factors for. Okay, which is a little ridiculous. All right, so here we go. 3k and k, 1 and 7. Let's see. And don't forget to bring down your 3. So let's see if this makes it. So that's 21. All right, and that's k. So that makes 22k. Did I want 22? Yeah. Okay. Again, I'm just throwing these in. I'm not even looking at what the answer is. I'm just throwing it in, and that just so happens to be the answer. All right. Now, we can use that same method. Now, these are going to look a little funky. Do you notice we have 2 variables in here? Don't let it scare you. Okay, you can use the AC method if you want. Here, you can even use trial and error here. It doesn't matter. I'll do the AC first. The A is a 1. Okay, so that's 1 times negative 5 is negative 5. Okay, factors of negative 5 that add to 4, negative 1 and positive 5. All right, so here, I'm going to split up this using 5, and make sure you put xy with both of them, and then negative 1 xy minus 5y squared. Now, group it, And it doesn't matter which order you put these two in. I did it like this, and I actually did it like this for a reason, because this one, so I can show you something on that one. All right, right here, what's alike? X. So I'm left with x plus 5y. All right, here, if that front number is negative, make sure you pull out a negative. So I'm going to pull out a -1, but then I also notice a y, so -1y. All right, so I'm left with positive x and a positive 5y. Double check that these two parentheses are the same. They are. Put the two GCFs together, and then the one you see twice, write it once. All right, here we go. Number 13. Now, you can still use trial and error on this one, on these like this too. You can say, okay, factors of 30. Okay, well, like 1 and just put x's with them. 30, 2 and 15, 5 and 6, 3 and 10. I think that's it. So I actually have a lot of factors here. Now, the only factors of this are y and y, 1 and 1. Okay, so the back part is actually going to be pretty easy. We don't have any choices but y and y, and they're both positives. If you see pluses all the way across, it's just going to be pluses in there. Okay, so just throw something in there. Okay, so let's do 2x and 15x. So it doesn't matter which one you do. Multiply the last, that's 2xy. Multiply the middles, 15xy. That adds to 17xy. Well, what did I want? 11. So it's not that. Even if I switch these two, is the same thing. So I can't do that. All right, let's just 5x and y, and then 6x and y. All right, 5x times y is 5xy. That's going to be 6xy, and that's 11xy. All right, did I want that? Yep. So there's our answer right there. All right, and that's how you factor it. Now, another type of factoring that you learned was the difference of perfect squares. All right, the difference of perfect squares. That's when it's like this, is in that form. Basically, and you have to have a minus. I'll tell you what happens when you have a plus. It's two perfect squares. All right, you create two parentheses. You take the square root of the first, a and a, square root of the last, b and b. One's a plus, one's a minus. Doesn't matter which one's which. Now, if it's a plus, then it's not factorable. Okay, as long as, make sure GCF doesn't pull out. GCF doesn't pull out. It's not a difference right here, perfect squares. It may look like it, okay, but when I do it, it's not factorable. So we say prime. All right, so let's try, and I guess that's not really number 14. All right, let's try some of these. All right, x squared minus 4. If you want to stop it for a second and you do it, you go right ahead. Okay, here I notice they're perfect squares with a minus. Take a square root of that, x and x, 2 and 2, one's a plus, one's a minus. That's it. You can check it by multiplying it, but it does not matter. All right, 9x squared minus 49. All right, so here we go. I notice perfect squares, no GCFs to pull out. So here, perfect square of that is 3x. The square root of that is 7. One's a plus, one's a minus. All right, double check that that's always a minus to begin with. All right, 16. 16x squared minus 4. Now, a lot of you are going to be very quick to say, okay, those are perfect squares with a minus, so 4x minus 2, 4x minus 2. But look at this for a second. A 2 comes out of both of these. So I really haven't factored it all the way. Okay, and here you actually, when you pull out factors like that, this isn't grouping, okay? I didn't do grouping right here. So I'm not like putting them in parentheses together. I actually multiply those, and that's 4. 2x minus 1, and 1's a plus, sorry. Like that. Now, had I looked at it to begin with and said, oh, wait a minute, there's a GCF that pulls out. It's 4. I'm going to pull out a 4 first. So that's 4x squared minus 1. Don't forget, 1 is a perfect square. Okay, square root of that is 2x. Square root of that is 1. 1's a plus, 1's a minus. I get the same thing. It's actually in a fewer steps, and it's a little less confusing. So double check that there's not a GCF that pulls out first. All right, let's look at this one. Okay, 24g squared minus 6. Now, it's in the form of different perfect squares because it has two terms with a minus, but they are not perfect squares. What did I say I always look for first? GCF. So what's the GCF that pulls out? 6. So that's going to leave me with 4g squared minus 1. Kind of similar to what I just had. Let me clear it up for us. Okay, so here, perfect square minus in the middle. Square root is 2g. Square root of that is 1. 1's a plus, 1's a minus. And here's our answer right there. Okay, and 18. Okay, 25x squared plus 9. You do this one for a second. All right, did you say it was 5x plus 3 and 5x minus 3? If you did, you're incorrect. Why? Why are you incorrect? This plus right here. Remember, anytime it's a plus, it's prime. So this one is not factorable. All right. Now, the last type of factoring I'm going to talk about is grouping. Okay, you actually saw this with the trinomial. So I'm kind of working backwards here. Okay, if you ever see 4 terms like that, then group the first 2, group the last 2, and you're looking for GCFs that pull out. Double check that these are the same. If they aren't, then it's not factorable. Okay, or maybe you didn't pull out the highest thing, or maybe you didn't do it correctly. Okay, here, put the two GCFs together, and then the one you see twice, write it once. Okay, so let me go do another one. 2x to the 5th minus x to the 4th plus 2x squared minus x. Group the first 2, group the last 2. I can take out x to the 4th, and I'm left with 2x minus 1. Here, that's a plus right there. Okay, I can take out an x, so plus x. All right, and I'm left with 2x minus 1. All right, so x to the 4th plus x and 2x minus 1. Now, don't be too quick to leave this one. All right, remember what I said, always look for GCF. Okay, I was really quick at doing this by grouping, and I should have looked at that GCF to begin with. If you actually look at it, an x pulls out. But that's okay that I didn't catch it here, because guess what? I can catch it in the end. All right, so always look for it in the end that a GCF doesn't pull out of one of these parentheses, or both. Okay, so here an x pulls out, and that's x cubed plus 1, and then 2x minus 1. All right, and we got one more problem. 56xw plus 49xk squared minus 24yw minus 21yk squared. Holy moly, that's a lot. But what I see is 4 terms. Okay, so I'm going to group the first 2, group the last 2. All right, what's in common between 56 and 49? 7. All right, going to pull out a 7. They each have x. No w, no k. So I'm just going to leave it like that. So 7 goes in there 8 times w. Plus 7 goes in there 7 times k squared. Okay. Here, remember, if there's a negative right here in this second parentheses, you're going to pull out, the thing you're going to pull out is at least going to be negative. But what's common? Negative 3. Okay, and I see a y. So here we go. That's going to turn to positive, so that's 8, and I'm still left with the w. That's going to turn to positive, so that's 7, and I'm left with k squared. Double check, are my parentheses the same? Yep. 7x minus 3y. All right, and then 8w plus 7k squared. But what are you always looking for to make sure we don't have? GCF. Do I have a GCF that pulls out? No, I don't. So I'm good. All right. So this is a review of factoring. We are going to learn one more type of factoring, but that's a factoring that we do in Math 3. So we'll learn it another day. It'll be pretty quick when we learn it. Okay, but make sure you understand all this. All this is from really Math 1. Okay, and then you hit it again in Math 2, and then we're going to use it more in Math 3. So make sure you're pretty good at factoring. It's not going away. Either you're going to see it in Math 4, you're going to see it in pre-cal. We do a lot of the trinomial factoring in calculus. Not really the hard stuff, some of the easier stuff, but you got to be quick at it. All right? If you need additional help, please come see me.